All right, you guys, so for the second one, when we're doing quadratic arithmetic or computations, the two problems that I posted on here are exactly copied from the test. I just changed the numbers for you because there was really no other way to get to help you guys feel comfortable with this. And I know for a fact that these were copied from SAT practice tests. So this will be good practice for next year when you take the real SAT. So let's take a look at the first one. The first thing we're going to use is substitution. If you look, this says that z is equal to a squared plus b squared, and that ab is equal to y. So if you take a look over here, here's z. So instead of z, when I substitute back in, I'm going to put a squared plus b squared. And over here, I'm going to rewrite this in instead of y, I'm going to go ahead and put ab. So let's go ahead and do that. So we're going to say 3 times a squared plus b squared. And we're trying to figure out what could possibly be equivalent to this. The question on the test, let's see if I can talk and do this at the same time. The question on the test is going to be multiple choice. So you're going to have to just keep simplifying what I wrote down until you find one of the answers, okay? I'm not sure what that's going to look like, but here the first thing I'm going to do is distribute this 3 and then multiply the 6. So we have, what this ends up being is 3a squared plus 3b squared plus 6ab. It's not 6a and 6b because ab is one term. A term is when you're multiplying things together. So this is one term here, okay? And then what I hope you notice is that 3 and 6 all have a common factor, and that common factor is 3. So we're going to factor out a 3. And remember, when I factor something out, it's the same as dividing. Okay, so I'm going to factor it out. So what is 3 divided by 3? That's just 1. But remember, I don't really write the 1. That's kind of baby talk in math, so I'm just going to put x squared plus, and then this is also 3, so this is just going to be b squared. And then plus, this is going to be 6 divided by 3, which is 2ab. Okay, and I think you guys are going to be able to get here fine. It's this next part that is a bit tricky, so you might want to annotate this on your own notes. And remember, you can use your notes on your test, so you might want to do this. Now, this 3, I'm just going to kind of let hang out here because whatever I do with the, bless me, whatever I do inside the parentheses, I'm just going to multiply 3 at the end. Okay, so do not forget this 3 is here, but we don't need to worry about it right now. What I am going to do is set up an area model like this. And then if you remember, this is the area written as a sum. So these are going to be my inside pieces. So I'm going to put a squared here, and I'm kind of doing this, I know where they should go, so don't feel bad if you didn't know which box they should go in. This is just a lot of practice, years and years of practice. So I have an a squared and b squared. And remember, I only have 3 pieces, but I have 4 places, but luckily this says I have 2 ab's. So I'm going to put 1 ab here, and I'm going to put 1 ab there. So I have 2 ab's. Now, remember, it's that puzzle where we figure out, to factor it, we figure out what's on the outside. So I'm thinking to myself, what times what is going to give me a squared that really makes sense? And I hope you get this before I write it. It's going to be a times a. And once you have, that looks like a 9. Once you have one, like, part of it figured out, the rest is just like a puzzle, right? Now I'm thinking to myself, okay, let's look at this a. What a times what is going to give me ab? And that's going to be b. And b times what is going to give me b squared, and that's going to be b, and then a times b is ab. So, and these are all positive. Cool. So I'm going to go up top here because I'm running out of room. So what I have now is, remember that 3, don't forget that 3 is still there. So this is going to be equal to this 3 times, and then my sides, a plus b times a plus b. And then remember, if these are both the same, it could possibly look like 3 times a plus b squared. So here's the tricky part, you guys, or at least one of the tricky parts of this whole thing, right? Is that, and I'm trying to find a good color highlighter here, let's do green, is that this could be the answer. This could also be the answer. This could possibly be the answer. This could be the answer, or this could be the answer, because the question is asking what is equivalent, where they are all equivalent, right? So you have to keep simplifying until you find one of the answers. Or it could be one of those horrible questions that says, click all that apply, in which case maybe they're all correct if they each look like this. I don't think that's the case. I think it's just one on this test, but so you are always prepared. Okay, the second one under part 2, the second one is where we talk about, this is the difference of squares. Difference because that's subtraction, and difference means subtraction. And 16x squared is a perfect square, and 36 is a perfect square. I'm going to rewrite it so I can show you what I'm talking about here. 16x squared is a perfect square because 4x times itself is 16x squared, right? And 36 is also a perfect square because 6 times 6 is 36. The subtraction is different, so the rule is, when you rewrite it, you write out your two sets of parentheses, and you're going to put what makes the 16x squared, and then you're going to put what makes the 36, and since we're multiplying and we need to get a negative, one of those needs to be positive, and one of those needs to be negative. So I can factor this using that rule, and that's really easy. The hard part for this one is it is set up really strangely because it's an SAT problem. So it says 16x squared minus 36 is equal to px plus t times px minus t, right? In this equation, p and t are constants. That just means numbers. What could be the value of p? So just look at where that p is. It's p times x. It's the coefficient of x. So we know, oh, that didn't work really well with the purple last time. Let's change it to yellow. So we know that this is where that p was. So the answer is 4, right? What could be the value of p? That value is 4. All right, let me know if you have any questions. That was question 2.